I want to talk about finding the force in the parallel and perpendicular direction, okay? Now I'm given a vector here on an inclined plane, it's inclined plane, okay? So in this case, I use a gravitational vector, so I did a little bit more calculation, but you could use, I could have used a vector of A with some sort of magnitude, which is in newtons, okay? But I gave you a gravitational vector, but anyway, okay, so we have it on inclined plane and we're asked, okay, well, what is the force in the perpendicular direction and what's the force in the parallel direction? Okay, well, how do we solve this? So remember, these types of problems I always say, okay, well, the inclined plane is just too unclear for me. Okay, it's just too unclear for me. And so the first thing I do is at the tail of the vector, I draw a line that's perpendicular with the axis. And so if I'm looking at this, here's my perpendicular line. I'm going to line my perpendicular line right up with that perpendicular line. And so if I look at this, if I take my ruler and size it up nicely and then draw a perpendicular line, okay, boom. Now I have something that looks like this. So here's my perpendicular line, okay, and then I already have an arrow out here, so I'm just going to draw a stopping arrow here. And if you look at this, now the picture becomes super clear. It looks as if you're just dealing with a regular four quadrant type of angle with your vector being in the third quadrant. So that's just the reason why I like doing that. Now, with also doing that, it benefits us, okay? Because we know that phi, in this case, is 27 degrees. So this is 27 degrees. Well, what do we also know? The sum of the angles in a triangle adds up to 180. And so we know that this is 90 degrees. So what is this angle? Well, if I take 180 minus 90 minus 27, this angle shall be 63 degrees, since the sum of the angles in a triangle must add up to 180 degrees. Now, with that being said, the problem just becomes very simple, okay? So we know the force in the parallel direction. Well, that's just, okay, so, well, perpendicular. Let's do perpendicular first. So FG perpendicular, well, that's just equal to the force times cosine of the angle. It's magnitude times its unit vector. That's all we care about. Magnitude times its unit vector. So I'm looking at this, the magnitude of force times its unit vector. Okay. So we know that what the magnitude is in terms of, in this case, we're dealing with a gravitational force. Okay. And so we know the magnitude of gravitational force, and we can simplify this. And so this would be mg. Okay. This would be mg cosine of theta. In particular, this will be, so it'll be mg cosine of theta, okay? So now the big idea becomes, well, what is theta? Okay, we need to get this angle right in order for us to get the answer right. And so if I go back up to my kind of graph, if you want to call it, okay, here's my perpendicular line, okay? So here's my perpendicular line, here's my vector, okay? So from the perpendicular line to the vector is always how we do it. And in this case, I'm always going to go anti-clockwise because I want to keep everything positive. I don't want to have to deal with, okay, well, this is angle negative since I'm going in there. Yeah, I don't care about that. Even if I have to go all the way around the unit circle, I do it always in a positive direction, okay? So from the perpendicular axis, if I go from here to here, I cover 90 degrees. If I go from here to here, I cover 63 degrees. And so, in fact, this would be mg cosine of 90 plus 63. Okay, and if we put this in our calculator, we'll take the mass, which is 2 kilograms, times the gravitational force acceleration, which is 9.8 meters per second squared, and we take cosine of 90 plus 63. If we plug that onto our calculator, we shall get negative 17.5 newtons. Okay, so if you plug all this into our calculator, we shall get negative 17.5 newtons. And so FG perpendicular shall be negative 17.5 newtons. Okay. Now, my question to you is, what about the perpendicular direction? Well, again, we know, not perpendicular, parallel. We know FG parallel, that's just equal to the magnitude of the parallel force times cosine of the angle, which is just a magnitude times its unit vector. That will give us the force. And so if I'm looking at this, we know the gravitational force is just mg. And so this is mg cosine of theta. Well, the answer is, my question to you is, what is theta? Well, if we go back up to the problem, here's our parallel direction and we start. So this becomes, if we go from here to the vector, this becomes 90, 90, 63. So this becomes 90 plus 90 plus 63, and we could simplify that to be mg cosine of 180 plus 63, since 90 plus 90 is 180. And so if we plug 2 kilograms, sorry about that, as you can see this, so we plug 2 kilograms times the gravitational acceleration is 9.8 meters per second squared, times cosine of the angle 180 plus 63, then we shall get our answer to be negative 8.90 newtons. So FG parallel shall be negative 8.9 newtons. Okay, so there goes our answer for the parallel one, there goes our answer for the perpendicular one. And this is how we kind of solve these problems.